In this video, we're going to explore the Wronskian without getting too deep into the weeds. We're going to try to look at what it tells us, how to calculate it, and what its uses are, essentially. The Wronskian determinant is basically used to tell you if the solutions that you found to a second order linear differential equation are indeed correct, if they encompass all possible solutions. And earlier we saw that we have solutions of this form: C1 y1 of t plus C2 y2 of t. Why do we have y1 and y2 rather than just 1? That's because it's a second order linear differential equation, so there are going to be two, right? Second order, just like with quadratics, you have two roots, you'll have two over here. And this should essentially cover all possible solutions to a second order differential equation, linear differential equation. And when you want to test that, you use what's called the Wronskian. And the Wronskian is just equal to, it's going to be equal to the determinant of y1 of t, y2 of t, and then over here you have y1 prime of t and y2 prime of t. If you're familiar with determinants, you should know that this is just y1 y2 prime minus y2 y1 prime. I've omitted the brackets t for all of them because it's just a lot of space and a lot of writing, but you know what I mean. So this is a Wronskian determinant, right? These are all equal. And how do we determine anything from this? Well, when the Wronskian, and another way to write this, like to make this a bit more compact, instead of writing out that whole thing, you can just say y1, y2, and that will mean the exact same thing as all this. When this is not equal to 0 at t equals t0, and t0 is the point of the initial conditions that are given. Remember that for this, we'll be given some initial conditions like y of t0 equals y0 and y prime of t0 equals y0 prime. Right? These are all general things here, but when we're given something like this, so these are the initial conditions. As long as the Wronskian is not equal to 0 at t equals t0, y1 and y2 become solutions of the differential equation given those initial conditions. If you will recall from last video, we examined this differential equation, so let's just write it again. Y double prime plus 5y, y double prime plus 5y prime plus 6y equals 0. We found the characteristic equation to be r squared plus 5r plus 6 equals 0, which gives us r equals -3 and -2. And if we just omit the initial conditions, we get a general solution of C1 e to the -3t plus C2 e to the -2t. Okay, and when we want to look at the Wronskian here, if you try to match this to the form that we saw above, which was this one, C1 y1 plus C2 y2, we'll see that y1 over here is e to the -3t and y2 is e to the -2t. So let's go ahead and find the Wronskian. There are no initial conditions, so we're going to see how we tackle that. Let's take the Wronskian. So y1 comma y2. This is again just going to be the derivative of y1 over here. We're not going to write y1 again, we're just going to write what it actually is, e to the -3t. The derivative of that is -3 e to the -3t. Over here we have y2, which is e to the -2t. This is -2 e to the -2t. Let's find that derivative. Well, first we will multiply it diagonally like this. That's going to give us, I'm going to go ahead and write it here, -2 e to the -5t. And then over here we have minus -3 e to the -5t, which ends up becoming just e to the -5t. Now, is this ever equal to 0? It's not equal to 0 for any value of t. So no matter what our initial conditions are, this is never equal to 0, meaning that this indeed will incorporate every possible solution to this differential equation. Going back here to our general solution, the y1 and the y2, so if you just omit these constants and separate them into y1 and y2, this forms an FSS. And you can probably guess what an FSS means from the title of the video. It's a fundamental set of solutions. So it's going to be y1 and y2, those are your fundamental set of solutions, and you can form a linear combination of those, c1 y1 plus c2 y2, and this over here is going to be your general solution. And that's about it for this video. We'll do a few more practice questions, and then we'll examine other cases when we slightly tweak these numbers and we get pretty different results. So I'll see you in the next video.